Hello, thank you for watching this video. So in this video I'll be doing question 1 of November 2022 question paper mathematics paper 1. So I'll be doing question 1, which are mostly equations. So question 1, 1.1, solve for x. So they want you to solve for x for the following equations. 1.1.1, you have 3x minus 6 times x plus 2 is equal to 0. They want you to solve for x here. So what does this, like when you're looking at this, that's saying find the value of x. But what value of x? Why? So they want you to find the values of x such that they satisfy this equation. That's what they're asking you to do. Find the values of x that will satisfy this equation such that when you multiply this bracket by that bracket, you get to 0. Right? So, if you have, let's look at this. If you have x and y, the product of x and y equals 0. What you can say your x is equal to 0 or your y is equal to 0. At least one of them should be 0. So if you're multiplying two things and your answer is 0, at least one of them is 0. That's what you should always know. So, looking at these two brackets here, you have this bracket times that bracket, and you're told that the product of these two brackets is 0. What does that mean tell you? It tells you that at least one of them should be 0. That's what it's telling you. So that's how you look at this. So you want to find the values of x that will satisfy this equation such that this bracket is 0 or that bracket is 0. That's what it means to be solving your x here. So if you're saying, so now what this equation is telling you, I'm repeating this many times. It's telling that the product of this bracket and that bracket is 0. So what that tells you, either this bracket is equal to 0 or that one is equal to 0. So you say, okay, 3x minus 6 is equal to 0 or x plus 2 is equal to 0. Because if this bracket is 0, then the product of the entire thing will be 0 and this equation will be satisfied. Similarly, if this bracket is 0, that means the product of these two brackets will be 0. This equation is satisfied. So you want the values of x such that the product of these two brackets is 0. So for this part to be 0, that means your x. So your x, you must find the x value such that this bracket here is 0. So you transpose this to the side. 3x is equal to 6 divided by 3 divided by 3. Your x is equal to 2. So what this tells you is that for this bracket to be 0, your x should be 2. So if you take this 2 here, okay, let me just stop here. And then for this bracket to be 0, that means your x is equal to minus 2. So for this to be true, your x should be an element. Of minus 2 and 2, which is x should be in this set. That's what this tells you. And you're done with this one. Because you want the values of x such that this equation here is satisfied. That's it. You're done with this one. Let's go to the next one. So solve for x here as well. 2x squared minus 6x plus 1 is equal to 0. Correct to two decimal places. So that correct to two decimal places, which means this thing doesn't have like nice factors like rational like factors. So let's use the quadratic equation straight away. So we say, okay, my quadratic equation is called x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So this part here is your A, and this part here is your B, and that part there is your C. Right? So x is equal to negative b. What is your b? Your b is minus 6. This part here. Plus or minus square root of b all squared, which is minus 6. All squared minus 4. A, what is my A? My A is 2. And my C is 1. All over 2a. What is my a? It's 2. Then you punch this in the calculator. Your x is equal to, or your x is equal to. Punch this in the calculator. Minus 6 plus square root of minus 6 all squared minus 4 into a over 2 into a. So we have x, which is 3 plus root 7 over 2, and x is equal to 3 minus root 7 over 2, and this one here is equal to 2.82, and this x here is equal to 0.18. These are your solutions for x. Just use the equality equation, straightforward. And then let's clean the board and move to the next question. So this is an inequality, right? Inequality equation. So first thing you do, transpose this to the side. So you have x squared minus x minus 90 greater than 0, right? So you want to find your critical values here, where this equation of yours is equal to 0. That's what you need to do. Find your critical values. So say you want, okay, our critical values for x squared minus x minus 90 is equal to 0. Factorize this, or you put it in a quadratic equation, because this is similar to 1.1.2, the one we use the quadratic equation. You can use the quadratic equation here if you can factorize. So x, we have 9, we have 10, minus, we have plus. So x is equal to minus 9, x is equal to 10. So your critical values are x is equal to minus 9 and x is equal to 10. So, but you want to find this the set of x values that will satisfy this equation, or equivalent to this one, because these are equivalent. So the one that I find easier is this one here. Find easier to work with, because this is a parabola, this one. So you can just draw a rough sketch of it. You can be like, okay, here's my parabola. It will look like this. This is my y, this is my x, right? My intercepts at minus 9, somewhere maybe here. It doesn't have to be neat. And 10 is somewhere here. So to draw this, say, okay, it's a positive parabola. It has this smiley face here. So this should be 10 here. 10 here. 9 here. So 9 minus 9, 10. So this is our function, right? So you want the values of x where our function, this one, which is this, is greater than 0, which means where it is positive. Where is it positive? So here is positive because it's above the x-axis. Positive, 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 0 here. Negative, 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 negative because it's below 0, right? Negative, negative, positive, 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 above the line y is equal to 0, because this is x-axis, right? X-axis or line y is equal to 0. This is the y-axis or line x is equal to 0. So here my y is equal to 0. Above here is positive, here is negative, right? So above here y is greater than 0. Here y is less than 0, below. And here on this line y is equal to 0. So you want where your equation is greater than 0, where it is positive. It's positive here and there, right? So what are the values of x then? So it's these values here. You can say the values this direction. So those values are less than 9, and the values to that direction. Those values are greater than 10. So your x values, x is greater than 10, or your x is less than minus 9. Or you can write it x is an element of minus infinity, from infinity to minus 9, right? Union what? 10 to infinity. This is how this looks like, which means you're just taking the union of this set and that set, you're just putting them together. That's what you're doing here. But you don't have to write this, but that, because our function is positive greater than 0 here, which the corresponding x values are these ones, they're less than minus 9, and here the corresponding x values are these ones, greater than 10. That's how you do this one. Then you move to the next question. So you're asked to solve for x here as well, right? So the first thing to do when you're dealing with such things is to notice the relationship between this guy and that guy there. What is the relation between this guy and this guy? So if you look at it, you have x minus 7, x raised 1 over 2. You know from sets that square root of a is equal to a raised 1 over 2. We know this from sets. We did sets at grade 11. So this is that by definition. Okay, is equal to minus 12. Let's look at it again. What's the relation between this and that? So this is raised by half, and that one is raised by 9. It is raised by 1. So what you can quickly tell is that the power of this is 2 times the power of that. The power of this is 2 times the power of that. Which means what you have here, we have x raised 1 over 2 times 2 minus 7 times x raised 1 over 2 is equal to minus 12. Which is similar to saying this is the same as x raised 1 over 2. 2, which is same thing, right? Minus 7 x raised 1 over 2 is equal to minus 12. This is what you have. Then you can transpose the 12 to the other side. So you have x raised 1 over 2 minus 7 x raised 1 over 2 plus 12 is equal to 0. If you look at this, oh sorry, should be a true there. If you're looking at this, you'll quickly realize that this resembles exactly what we had at 1.1.2. At 1.1.2, we had something along the lines of 2x squared minus 6x plus 1 is equal to 0. This had exactly the same shape, except that we have 2 x, you can write it this way, 6x plus 1 is equal to 0. These two things are similar. And here, you solve for x here, right? Which means here you solve for 1 over x raised 1 over 2. Because here you solve for x here when you use your quadratic formula. Here you're solving for your x raised 1 over 2, right? So what you do now, say, okay, I want to solve, I will solve the x raised 1 over 2. But eventually you must go to solving x. Someone else might use what they call K method. Let this thing be K and then solve it. So allow this thing to be K. Maybe I should do that. Should I? No, I don't want to. Use the K method if you can. I don't want to do that. Let's just go straight to the point. So what we have now, say, okay, you can say factorize this or use your quadratic equation to solve x raised 1 over 2. I'll factorize it and say, okay, here I have this x raised 1 over 2 and x raised 1 over 2. This is minus 3 and this is minus 4, right? That means my x raised 1 over 2 is equal to, similar thing to what I said on the first question. This is the step we had in the first question. You want to solve for x raised 1 over 2, right? So for this, what if the product of this bracket and that bracket are 0, which means this bracket is 0 or that bracket is 0. So what we have here is, for this to be 0, or for this to be 0, this part, which is x raised 1 over 2 minus 3, should be 0. Or x raised 1 over 2 minus 4 should be equal to 0. Right? And then, now solve the x raised 1 over 2 is equal to 3. Or x raised 1 over 2 is equal to 4. But what do I want? I want to solve for x. That's what they asked me. So multiply by 2 there. There's 1 here. Multiply by 2. There's 1 there. Multiply by 2. Multiply by 2. So this and that cancels out. You're left with x is equal to 3 squared. This side, we're left with x, because this and that will go out, is equal to 4 squared. X is equal to 9. X is equal to 16. This is what this means. Get your x. So the most important part is just recognizing the relationship between these two. That this is twice, the power of this is twice the power of that. Then you can split them and make them look similar. Once they are similar, you treat it as your 1.1.2 like type of question. And then this is it. Hopefully it's correct. Okay, we're done with 1.1, which is solving for x. I'm going to clean the board and then go to the next ones, which is 1.2. So 1.2 reads as follows. Solve for x and y simultaneously. So they want you to solve x and y simultaneously, which is now, what do you have? You have 2x minus y is equal to 2. And xy is equal to 4. They want you to solve x and y simultaneously. So what I always look for here, I always look for the simplest equation, So the simplest equation is this one. So from the simplest equation, make x or y the substitute of the formula, whatever that you find easier to do. So in this case, y is the one that can easily make the substitute of the formula because it doesn't have any big coefficient. This coefficient is 1. So I can transpose y to the other side, right? So what I'm going to do, from this equation here, I'm going to transpose y to this side and 2 to this side, right? So I'll have 2x, then transpose the 2 to this side, minus 2 is equal to, this y was negative, it will be positive on that side. So I'll have y equal to that. So this equation and this equation are the same, but I just arranged them. That's what I did. Now that I've arranged this equation, I'm going to substitute this first equation on this one, because I call it the first equation because it's a rearranged version of that. It's not a new equation, it's the same one, but I've just rearranged it, right? So I'm going to substitute this first equation of mine on this second one, which means now I have my x, which is this, and y. My y now is this part. So when I see y on this equation, I'm going to substitute this because I said this is equivalent to y. So I have 2x minus 2 is equal to y. Sorry, it's equal to 4. It's equal to 4. What do I have? I have 2x squared minus 2x is equal to 4, right? I have 2x squared minus 2x is equal to minus 4 is equal to 0. I transpose the 4 to this side. So I can divide by 2. Divide by 2. What do I have? I have x squared minus x minus 2 is equal to 0. Factorize this. X here, 2, 1, minus plus. So what do I have? And x is equal to 2. X is equal to minus 1. So now that I've got the x values, I want to find the corresponding y values, right? So if my x is equal to 2, my y is equal to 2 times x, which is 2, minus 2, which is equal to, this is 4 minus 2, which is equal to 2. So my coordinates will be 2 and 2. My corresponding x and y, x and its corresponding y value. But if my x is equal to minus 1, my y is equal to 2 into minus 1, minus 2. This is minus 2, minus 2, this is minus 4. So my corresponding x and y values is minus 1 and minus 4. These are my coordinates. So I've solved the x and y simultaneously. I hope this is what they're asking for. We're done with 1.2. Then go to 1.3. They're saying show that this 2 times 5 raised n minus 5 raised n plus 1 plus 5 raised n plus 2. They are saying show that this thing is even for all positive values of n. Okay. Show that this thing is even for all positive integer values of n. They want us to show that this thing here is even for all positive integers of n. So for all positive integers of n. That's what they want us to do. For all n is a positive integer. You know what integers are, right? Integers are these numbers here. Is 0, minus 1 and 1, minus 2 and 2, minus 3 and 3, and so on. These are the integers. Or some people write them like this. They say, okay, they are coming from the smallest to minus 2, minus 1, 0, 1, and 2, and so on. This is how some people write them. So these are integers. So they're saying for all your integers that are positive, which is from 1 going to that side, this is even. That's what they are telling you. They're saying this thing is even for all. So this thing for all, this thing here is even for all these things. It's even. So it is even. For all n is a positive integer. So they're saying show this. So how do you show this? The first thing that you should understand is the term even. What do they mean by even? So you must know the definition of an even number. Once you know the definition of an even number, you can easily show that this thing is even for all n is a positive integer. So what is an even number? You know even numbers. Examples. Let's say the examples. Look at examples. The ones that are common examples of even numbers. You can say 2, 4, 6, minus 8, 10, 20, whatever, or minus 6, and so on. You can list many, infinitely many even numbers, right? So you know them that these are even numbers. These are the examples of even numbers. But what is an even number, right? So an even number is any number that can be written as an even number is any number that can be written as an integer times 2. That's the definition of an even number. So it is any number that can be written as an integer times 2, or it can be expressed in the form 2 times k, where k is an integer. So an even number is any number that can be written as an integer multiplied by 2, which means an even number is any number that can be written as an integer multiplied by 2. Look at this one, at 2 for example here. So 2 is even because 2 is equal to 2 times 1. This is, which is 2 can be expressed as an integer times 2. 4 is also even because it can be written as 2 times 2, which means it can also be expressed as an integer times 2. That's the definition of an integer. Take 5, take 10. 10 is also even because it can be written as a product of an integer and 2, which means 2 times 5. This is our integer in this case. Take minus 6 is equal to 2 times minus 3, and this is an integer. So this is what an even number is. So now, if you want to show that this thing is even for all, positive integers of n, then you must show that it can be written as 2 times an integer. That's what you need to do. That's what you need to do. You must show that this thing can be written as an integer times 2, then that it is even. That's what you should be aiming for. Let's do that. So I'm cleaning these examples of mine. Yeah. So I'm rewriting this. 2 times 5 raised n minus 5 raised n plus 1 plus 5 raised n plus 2, right? So, okay, there's nothing much you can do here. This is 2 times 5 raised n minus 5 raised n, right, times 5 raised 1. Because you know that if you have n plus 1 there, so these, before it gets here, you are multiplying 5 and 1. You multiplied 5 raised n and 5 raised 1. Then you took one base and added the exponent. You know, for this from exponential simplification and stuff. So this is how this looked like before you got here. And this one is here. You can say the same thing about this one. So this was 5 raised n times 5 raised 2. Right? So when you're here, you can take out our common factor, which is 5 raised n. So 5 raised n is our common factor. It's out here. So here we're left with 2 times 1 here. Minus 5 raised n. 1 here times 5 raised 1. Plus 1 here, because this has been taken as a common factor, times 5 raised 2. So you can punch this straight from your calculator. So it's 2 minus 5, which is minus 3, plus 25, which is, this is 22. So we have 5 raised n times 22, right? So 22, so this is the same as equal to 5 raised n into 11 times 2, right? And you can say, okay, you can group these two together and say this is 5 raised n times 11, right, times 2. So you know that the product of real numbers is associative. So you if you multiply a, so a and b, a, or bracket of a times b times c is the same as bracket of a times the bracket of a of b times c. So which means if you are working with real numbers, if your a, b, and c are real numbers, right, the a times b times c is equal to a times b times c. So the product of terms on real numbers is associative. So I just applied that there. Same thing. And it's also, yeah, so this is how you get here. And also you know that you don't have to do this, but you also know that it is commutative, which means the order does not really matter. So we can just say this is the same as, doesn't make too much difference. Doesn't make difference about 5 raised n times 11. So what you can tell here is that 5 raised n is an integer if n is greater than 0, or if n is your positive integer, right? So if this is always a positive integer, this would always be an integer as well. Because if it's 1, you have 5. If you have 2 here, it's 25. If you have 3, it's 125. If you have 4, you have whatever that is there. So this will always be an integer. 4 will always be an integer. 4 n is a positive integer. But we're told that that is the case, right? And here, this part here is an integer, and this one is 2. And you said an integer is any number that can be written as an integer times 2. So we have an integer here, because this is an integer and this is an integer. So the product of those integers is an integer. And this one here is 2. So this is even because it can be written as an integer times 2. That's what this is. That's how you do this. We're done with it. So we'll go to the next one. 1.4. I'm going to clean the board. Okay. 1.4. Determine the values of x and y. So determine the values of x and y. If, so they're like find x and y if 3 raised y plus 1 over 32 is equal to the square root of 96x. So they're saying find the values of x and y if 3 raised y plus 1 over 32 is equal to 96x. So to do this, ask yourself, what are the factors of 96? Find the factors of 96. So it's 32 times 3. So what you have here, you have the square root of 32 times 3, all raised x here is equal to this thing here, which is 3 raised y plus 1 over 32, right? And then what can we do here? We can say, okay, from definition we know that 32 times 3 raised x, so this is equal to this, all raised 1 over 2. We know this, right? So let's simplify this part. Say, okay, we have 32 times 3 raised 1 over 2x here, right? We can say that just take this one down as it is, doing nothing here. So now we have that 32 raised 1 over 2x times 3 raised 1 over 2x is equal to, what is it? 3 raised what? 3 raised y plus 1 all divided by 32. This is what we have, right? So what can we do? We can take this 32 and put it up here to the top. So we'll say, okay, 3 raised y plus 1 times 32 raised what? 32 raised minus 1 is equal to 3 times raised 1 over 2x, 1 over 2x, I hope it's visible, times 32 raised 1 over 2x, right? So which means this one here is equal to this, and this guy here is equal to that guy there, right? So what we have is, we can say, okay, 32 raised negative 1 is equal to 32 raised 1 over 2x. That means negative 1 is equal to 1 over 2x. Therefore, the x is equal to negative 2. Now that you have your x, you can say, okay, x is equal to minus 2. Let's go to the 3 part now. And say 3 raised y plus 1 is equal to, which is equal to that, 3 raised 1 over 2 x. But we have x equal to minus 2. So 3 raised y plus 1 is equal to 3 raised 1 over 2 times minus 2, which is our x there. Therefore, we have 3 raised y plus 1 is equal to 3 raised minus 1, right? So, if you're saying 3 raised y plus 1 is equal to 3 raised minus 1, we are saying these two things are identical, right? We are saying, if you're saying they're equal, you have 3, you have 3. If you're saying these two things are equal, in this case, you're saying this is identical to that. In order for this to be identical to that, it should also have a power of minus 1, which means here on top here, it should also be minus 1. You must try to achieve minus 1, find the value of y such that the sum of y and 1 is giving you that. That's what you're trying to achieve. So you want this top here to be the same as that one, because you're saying they're equal. If they're equal, which means they should have identical exponents. So what you have, you want to say this guy is the same as that one, which is your y plus 1 should be the same as minus 1, which means your y is equal to minus 2, because you're going to transpose this to that side. So your x and y values are minus 2 and minus 2. Those are x and y values. I hope they can also be seen. I'm doing these videos at night, so sorry. Hopefully I did question 1 very well and you'll be happy with it. Thank you for watching it.